Let's begin. Today's July 4th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 15, 16, 18, 19, and 20. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So on the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, and finally criteria card E. So criteria card A looks at our 3 digits, triangle, square, and circle, and the Turing machine will let us know which one is the absolute largest. Should triangle be the largest? Should square be the largest? Or should circle be the largest? Criteria card B looks at our 3-digit solution, and the Turing machine will let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? Criteria card C again looks at our 3-digit solution, triangle, square, and circle, and will add up the 3 digits, and the Turing machine will let us know whether the sum should be an even quantity or an odd quantity. Criteria card D will look at the first 2 digits, triangle and square, and we'll add them up and compare them to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should it be greater than 6? And finally, criteria card E will let us know a little bit about the structure of the 3-digit code. And specifically, it'll let us know whether there are no repetitions, as in the example 125, or it could be a double number where there's a repeating digit, as in the example 112, or finally it could be a triple number, a single digit repeated 3 times, as in the example 222. Remember, the objective of today's puzzle is to find this one unique code, 3-digit code, that abides by all of the 5 criteria cards we just discussed. And we're going to begin with an initial proposal of 314. So the first thing I want to test is I want to find out the ratio of even to odds. So let me go ahead and test criteria card B. Okay, so the Turing machine approves of my proposal. Notice that I do have 314, so I've got 2 odds to a single even. So the Turing machine approves of that ratio. So let me go ahead and type that up in section B, where even is less than odd. So again, I only have 1 even. It is less than the number of odds. Now, it doesn't mean that there are 2 odds to a single even. It could be that they are all odd and no evens. So, but at least we know there's at a minimum 2 odds. Okay, and so let's go ahead and test criteria card C. And in this case, the Turing machine does not approve of my proposal 314. So remember, criteria card C adds the 3 digits. So let's go ahead and do that with the initial proposal. So I'm going to add 3 plus 1, that's 4. 4 plus 4 is 8. That's an even quantity, but the Turing machine is telling me no, the sum should be odd. So let's go ahead and type that up in our notes in section C, that the sum of triangle plus square plus circle should be an odd quantity. And so that's going to tell us, I think, something rather important about the 3-digit solution. So again, the sum should be an odd quantity. I had even, it is incorrect, so it's odd. So again, going back to this idea of criteria card B letting us know that there are more odds than evens, remember the idea was that you could either have 2 odds and an even, or 3 odds. Well, in order to have a sum that, an overall sum that's odd, that means that all three digits must be odd. Because if you had the case where it's two odds to an even, well, the two odds add up and you get an even. And then if you add a third digit that's even, it stays even. So you actually need that third digit to also be odd. So I'm going to add a note up above here and just say they are all odd. Okay. Now we don't know anything about if they're doubles or not. We do have this criteria card E that could let us know that. And it is interesting that, again, we do know that there's an absolute largest. So we can already, well, actually, before that, I forgot, since I already said that they are all odd, let me go ahead and cross out all the evens for both triangle, square, and circle. That way we can focus on what potential solutions might look like. So again, in discussing the fact that if there is a pair, we would have to have that pair be the smaller variety of odd, meaning you can't have two fives because that third odd would be obviously less. So if there's a pair, it could only be either 1 1 or 3 3, and then obviously the third odd had to be greater. So there are, seems to be some more reduced solutions. So I'm wondering if we can somehow deduce some of these possibilities, and thinking what would be a good third Turing test for this round. So I'm looking at criteria card D, seeing what it could be. It could be a 6, but it could obviously be something less than 6. There are lots of possibilities. I'm wondering if testing criteria card E, which would let us know, well, again, it can't be a triple number, right? Because we do have an absolute largest. But it could be a pair, or they are all unique. So let's see. Yeah, let's go. I think I want to test criteria card E. I want to figure that out. So let's see. Okay, so it does agree with my proposal. Notice that I do have all unique digits, 314. So that means that not only are they all odd, but they are going to be 135. So there are no duplicates. Okay, well, that does it for this round. We've already done our 3 tests. Now we're going into the phase where we'll discuss how to construct a good second round proposal. So again, we do know that we're dealing with 135. So that means that whichever is the largest, whichever criteria card A eventually leads us to, that must be the 5. So we didn't test that, and we didn't test the sum of the first 2 digits. So let's see. What could happen? Again, we know that the sum is either less than 6, equal to 6, or greater than 6. Technically, there is only one, I think, one pair of numbers that add up to 6, and that's 1 5. And then perhaps criteria card A would let us know which one it is, and therefore force circle to be 3. Because well, let's see. Well, no, I guess the same could be said. Sum is less than 6, that's 1 3, yeah. And greater than 6, 3 5. Okay, well, never mind. But we do need to somehow, I think that's what's going to happen, is that criteria card D will set it up so that that circle digit gets forced into, either 1, 3, or 5, depending on what the sum is. So we do have to pick, I think, let's see, would it be wise to include the 3, whether it'd be 1, 3 or 3, 5? How can we, because yeah, we're down to, did I not, I guess I did not, I apologize, I did not write any notes for criteria card E. I did discuss that they were distinct, so let me go ahead and type that up. I apologize, I should have, no repetition. And of course that means that you're dealing with 1, 3, and 5. Alright, so we just have to figure out in what order. And again, it comes down to basically criteria card A and D. So let's see. Yeah, I really think it's a toss-up. There's really nothing that we can say. So let's say I'm just going to choose 513. I really don't think there's much for me to go on. And let's hope for the best. Alright, so the first thing, let's actually test criteria card D, the sum of the first 2 digits. Okay, so we were very fortunate that the sum is 6. Okay, that's great. And that was D. So let's type that up. So that means that triangle plus square having a sum of 6 guarantees that they are 1 and 5 in some order. And again, I think that's going to force the circle to be 3. So let me finish typing this up. Equals 6. Computer's lagging a little bit. Alright, so that means that yes, either triangle or square is the largest. So I think that's going to work out. So we'll test criteria card A, because at this point I don't think there's any, again, it's a toss-up. Okay, so it is not true that triangle is the largest, but because we know it's 6, that means square is the largest. So I'm going to write down, I'm going to deduce that square is the largest. And again, I apologize, my computer's lagging a little bit. Oh, I thought I pasted the square. Oh, there we go. Just a little slow. Okay, so that would mean that our solution is 153. So let's go ahead and type that up. I won't be crossing out anything because I think it, just from the information that we have in our notes, I think it's just safe to just go ahead and type it up as 153. And so if it's 153, we deduce that square is the largest. It is. There are more odds than evens, yes. The overall sum is odd, yes. The first 2 add up to 6, yes. And they're all unique, yeah. All right, so let's go verify on turingmachine.info. that our solution is 153, 153. Okay, excellent. But again, we do have to see how we did against the Turing Machine. I believe we did all, 5 tests. So that's a good indication where we're at least going to tie with the Turing Machine. And so I feel confident that it's going to be a win. So we did do BCE, and they are sort of alternating yes, no, yes, no, yes. So let's do BCE. So B is a check, C was wrong, E was a check, and that meant that we did A, but that was incorrect, and then D was correct. So let's see how we did. Okay, so awesome. So we did beat the Turing Machine by 1 question. So I think that was a good win. Looking back, trying to see, I think this combination, this interesting combo of cards that I tested in the first round, BCE, it turned out pretty well, where we were able to establish they were all unique odds. And so that really worked out. And then I think we just got perhaps maybe fortunate in the second round, because it was a toss-up. But having chosen all that, I think it really helped out to get the solution and the win. Well, if you saw anything interesting in the video, please do add a comment. If you liked the video, please do give it a thumbs up so that other people can find the channel. And if you don't want to miss out on any future videos, please do hit subscribe to be notified. Well, I hope you do enjoy this July 4th, and we'll see you next time. Have a great one.